Welcome back, dear students. In this video, we are going to cover Part 3, which is the last part of Chapter 2, Superposition of Waves. But before, let's remember about the vibratory state of points. We know that if two points have the same vibratory state, then they are in phase. If they have opposite vibratory state, then they are said to be out of phase or antiphase. Two points are said to be in phase if the distance between them is a whole multiple of lambda. And 2 points are said to be out of phase if the distance between them is defined by d is equal to 2k plus 1 divided by 2 multiplied by lambda, or an odd number divided by 2 multiplied by lambda. At the end of this video, you will be able to state and explain the principle of superposition of waves. What is the principle of superposition of waves? When two waves of the same nature, whether mechanical or electromagnetic, pass through the same point at the same time, they overlap. In this diagram, two waves, one in red and the other in blue, move towards each other. When they meet on the same point at the same time, they overlap, forming at this instant a new signal having a new amplitude. After superposition, the waves continue their way with their original amplitudes. Waves overlap in different forms. For this reason, there are two types of superposition: constructive superposition and destructive superposition. A constructive superposition takes place if the two signals have the same direction. That means the overlapping of two crests or the overlapping of two troughs. Let's explain it more. Before superposition, the signals A and B, having amplitudes y1 and y2 respectively, move towards each other. At the instant of overlapping or during superposition, the amplitude of the signal thus produced, A plus B, is equal to y. It is calculated using the formula amplitude of signal A plus amplitude of signal B, which is y1 plus y2. After superposition, the amplitude of signal A is y1, while that of signal B is y2. This diagram shows a constructive superposition of two crests of two signals, red and blue, moving towards each other. At the instant of overlapping, the amplitude of the produced signal in black is equal to the sum of the amplitudes of the two signals. After superposition, each signal moves with its original amplitude. Example number 1. In this example, we have two signals A and B having amplitudes y1 is equal to 2 mm and y2 is equal to 3 mm. During superposition, the amplitude of the signal A plus B is equal to y, which is equal to 2 plus 3 equal to 5 millimeters. After superposition, the amplitude of signal A will be 2 millimeters and that of B is 3 millimeters. Example number 2. Before superposition, the amplitude of signal A is 1 millimeter, whereas that of B is 2 millimeters. During superposition, if we want to find the amplitude of the signal thus formed, then we have to add the elongation of signal A and the elongation of signal B, which is absolute of -1 minus 2 is equal to 3 millimeters. After superposition, the amplitude of signal A is y1, which is equal to 1 millimeter, and that of B is y2, which is equal to 2 millimeters. After explaining the constructive superposition, can you guess what is a destructive superposition? Let's see. If two signals have opposite directions moving towards each other, they overlap at a certain instant on a certain point, then a destructive superposition takes place. In other words, it is the overlapping or the meeting of a crest and a trough. Let's explain it. Before superposition, the amplitude of signal A is equal to absolute y1, while that of B is equal to absolute y2. Remember that signal A forms a crest and B forms a trough, and they are moving towards each other. During superposition, or at the instant of overlapping, the amplitude of the resulting signal is given by absolute y, which is equal to absolute y1 plus y2. After superposition, the amplitude of signal A is equal to y1, and that of B is equal to y2. After superposition, the amplitude of signal A is absolute y1, whereas that of B is absolute y2. Solve with me this example to check your understanding. In this example, there are two signals of opposite directions. Signal A forms a crest and signal B forms a trough. Moving towards each other, they undergo a destructive superposition. The amplitude of signal A is 2 mm and that of B is equal to 3 mm. During superposition, if we want to find the amplitude of the resulting signal, then we have to add up the elongation of signal A and the elongation of signal B, which are y1 plus y2 is equal to absolute 2 plus minus 3, which is equal to 1 mm. After superposition, the amplitude of signal A is equal to 2 mm and that of B is equal to 3 mm. Example number 2. Before solving the example, let's look at the diagram. What is remarkable about it? Let's see. In this example, we have two signals, A and B. A is a crest and B is at a trough. They are moving towards each other and they have equal amplitudes, which is equal to 2 mm. During superposition, or at the instant of overlapping, if we want to find the amplitude of the resulting signal, then we have to apply the formula absolute y1 plus y2, which is equal to 2 plus minus 2, which is equal to 0 millimeters. Thus, the resulting wave has a zero amplitude, as you can see in this figure here. After superposition, the amplitude of signal A is equal to 2 millimeters and that of B is equal to 2 millimeters. After we have seen the superposition of two signals in this diagram, we will see an example of superposition of two waves. The same idea is applied here. Wave 1 and wave 2 are moving towards each other and they superpose to form a resultant wave. In the first and in the third case, a constructive superposition takes place because the two waves 1 and 2 are in phase. Notice that their crests overlap and their troughs overlap. The resulting wave in these two cases has an amplitude which is equal to the sum of the amplitudes of wave 1 and of wave 2. Whereas in the cases 2 and 4, a destructive superposition takes place because wave 1 and wave 2 are out of phase. Their crests overlap with their troughs. The resultant wave have a zero amplitude because these two waves have equal amplitudes. It is the same case that we have learned in example number 2. Where do we see the phenomena of superposition in daily life? It is seen at the surface of the water, where the two sources produce circular concentric waves. Because of the overlapping of these two waves, superposition takes place. What can we notice about this superposition, or how can we describe it? The red line joins all points of maximum amplitudes, where a constructive superposition takes place. Remember, it is the meeting of two crests or two troughs. The black line joins all the points of minimum amplitude, where a destructive superposition takes place. It is a meeting of a crest and a trough. Notice that this figure shows alternative, constructive, and destructive superposition. Try to solve this application alone before you see the solution. Two disturbances propagating in opposite directions are produced simultaneously in a chord. The following figure represents the state of these disturbances at t is equal to 0 seconds, when they are 4 meters apart. The amplitude of the red signal is 2 meters, and that of the green signal is 1 meter. Knowing that the speed of propagation is 1 meter per second, determine the state of the cord at the instant t is equal to 1 second, 2 seconds, and 3 seconds. At time t is equal to 1 second, the distance covered by each signal is d is equal to v multiplied by delta t, which is equal to 1 meter. Then, at this instant, each signal has moved a distance of 1 meter towards the other. Now, the distance between them is equal to 2 meters. At time t is equal to 2 seconds, each signal has moved a distance d is equal to 2 meters. Here we are calculating the distance covered by the wave from t is equal to 0 or from the initial position. These signals have moved 1 meter at time t is equal to 1 second, and then another 1 meter from 1 to 2 seconds. At this instant, the two signals overlap and a destructive superposition takes place because the red signal is a crest and the green signal is a trough. The amplitude of the resulting wave is y is equal to 2 plus minus 1, which is equal to 1 meters. At time t is equal to 3 seconds, the distance covered by each signal is d is equal to 3 meters from the initial position. We know that at time t is equal to 2 seconds, these two waves has overlapped and superposition has taken place. Then, from 2 to 3 seconds, each wave has moved backwards a distance of 1 meter. The red signal moves to the right, whereas the green one moves to the left with their initial amplitudes. Here is a quick animation for the motion of these two signals. What did we learn in this video? Let's sum up. 1. When two waves of the same nature, whether mechanical or electromagnetic, pass through the same point at the same time, they overlap. 2. A constructive superposition takes place if the two signals have the same direction. The amplitude of the resulting signal can be calculated using absolute y is equal to absolute y1 plus y2. The destructive superposition takes place if the two signals have opposite directions and the amplitude of the resulting signal can be calculated in the same way. Now it's time to sum up all the ideas of this lesson. Thank you for watching. Be prepared please for the next chapter.